Hello everyone, I'm Joaquín Lefranc. I'm a 10th semester student from Tecnológico Nacional de México, Campus Instituto Tecnológico de Querétaro, and co-author of the poster Optimal Condition of pH, Composition and Temperature in Synthesis of Cadmium Sulfide Thin Films by Chemical Bath Deposition. Let's start with the introduction. Semiconductor thin films are one type of advanced ceramic, which in current days it has been studied due to its several applications in electronic devices and their use in UV filtration. The CVD or chemical bath deposition technique is based on the immersion of substrates in solution. Is a non-expensive way to obtain high-quality thin films. The quality depends on factors such as chemical composition, temperature, pH, and deposition time. All these factors can be controlled. Throughout CVD, the precipitation of the material over the substrate is homogeneous, but could have been two sorts of mechanism, which are the homogeneous reaction, which is shown in the first part of Figure 1. This is commonly known as ion by ion. Nuclei are generated on the surface of the substrate, while over the time, new nuclei are formed by sulfur ions and metal ions, respectively. In the other hand, we have in the second and third part of Figure 1, it is explained the heterogeneous precipitation mechanism, commonly known as cluster by cluster. The colloid type solution form use an intermediate such as hydroxide ions or sulfur ions in the solution, which take a longer time to deposit over the substrate. Now about the method used, the reagents from chart 1 were needed, and the ones which are not specified, such as 0.1 and 0.5, are the ones that vary its molar ratios and are shown in second chart. Once prepared solution and with the substrates in the solution, beakers were placed in the bath. Deposition time for the thin films were 15, 30, 60, 90, and 120 minutes. The characterization was carried out obtaining the absorption and transmission spectra respectively, in a range of 300 until 1100 nanometers, with a HDR 6000 spectrophotometer. About the results obtained in Figure 2, we could appreciate the 1:9 molar ratio, thin films at the mentioned deposition times, and its residual solution, and a set of temperature of 90 degrees centigrade. Now, following with the results, in the left side are shown the ones for molar ratios variation, and the right side the ones for temperature variation. This is for Figure 3. It follows a tendency. While temperature increases, the average transmittance increases too. Now in chart 3 is shown the data from the average transmittance at 480 nanometers, because this is the most noticeable inflection point in transmission spectra. Now in the last figure, the number 4, is shown the top graph where calculating the energy gap by extrapolating the straight portion of the line of the graph versus the energy of the photon. Now for finishing, the growths obtained with a pH close to 10 favored the better growth of CdS films. An association was found between the molar radius with the gap, the energy gap. Findings data up to 2.72 electron volts. Molar radius with a higher amount of cadmium were inefficient for the formation of coating, homogeneous and well adhered to the substrate. The suggested mechanism for this reaction based on the results for these cases is cluster by cluster. Temperature is directly associated with thicknesses. The sine relation was the more temperature used in synthesis, the least average transmittance the thin film has, and an optimal temperature for growth is 70 degrees centigrade. Now, in acknowledgement, I'm infinitely grateful to Tecnológico Nacional de México Campus ITQ for providing its facilities, since without them, this investigation would not have been possible, and also the assistants who helped with the management of and provision of the materials. Now, there are the references. Thank you for your attention.